Hi guys, Ms. Body here from Advanced Algebra. Just wanted to prepare you for the virtual learning assignments online. Before you begin the first virtual learning assignment in Khan Academy, if you haven't started already, you're going to need these 4 skills. 1, simplifying radical expressions. 2, 3, and 4 are identities that you use a lot for the first 2 virtual learning assignments. I want to make sure you understand them because you really need to do the assignments for a grade. All right, so let's go. All right, simplifying radical expressions. First, you need a prime factorization. So for 84, since 84 is even, I'm going to go ahead and start with 2. 2 goes into 84 42 times. 42 is even, so I'll use 2. 2 goes into 42 21 times. 21 is not even, so I'll try 3. 3 works. 3 goes into 21 7 times. 7 is prime, so I can stop here. The prime factorization would be 2 times 2 times 3 times 7. That's the prime factorization. I should not be using 21 because 21 is not prime. Okay. I'm going to replace 84 with this prime factorization. 2 times 2 times 3 times 7. Okay. The prime factorization of x squared would be x times x. And the prime factorization for y cubed would be y times y times y. There's an imaginary index of 2 here, which lets me know that I need groups of 2. So I do have a group of 2 right here. I have a group of 2 x's. I have a group of 2 y's, and that's it. For each group, I can only take one number or one variable out. So for this group of 2's, I can only take 1 2 out. For this group of x's, I can only take 1 x out. For this group of y's, I can only take 1 y out. Everything under the radical that is not in a group will remain under the radical in the answer. Of course, you would simplify if you could. Like in this situation, I can simplify this. All right, 3 times 7 times y is 21y, so that would be my final answer. So I have 2xy times the square root of 21y. Okay, and that's the final answer. All right, so the square root of 84 times x squared times y cubed will be 2xy times the square root of 21y. That's the final answer. All right. What if I have a problem like this? I would do it the same way. So let's start with 81. I know that 9 times 9 is 81, so I'll use those. All right, and I know that 3 times 3 is 9, so I use those. 3 times 3 is 9. So I have 3 times 3 times 3 times 3 as my prime factorization for 81. So here I have 3 times 3 times 3 times 3. And then for x to the 4th power, that would be x times x times x times x. Okay, once again, there's an imaginary 2 as the index. So for each group of 2, I can take 1 out. So for this group of 2 3's, I can take 1 3 out. For this group of 2 3's, I can take 1 3 out. For this group of 2 x's, I can take 1 x out. And for this group of x's, I can take 1 x out. Okay, 3 times 3 is 9. X times x is x squared. So the square root of 81 times x to the 4th will be 9x squared. Okay, you'll have problems like these in Khan Academy, so if you didn't understand that, please rewind it. Make sure you understand it, okay? All right, there are 3 identities, as I said before, that you need to understand. These 3 right here, and I'm about to go over those now, okay? So, u plus v all squared equals u squared plus 2uv plus v squared. So where does that come from? Okay, so u plus v squared means that you're going to multiply u plus v times u plus v. When you have something squared, you multiply it by itself. So I'm multiplying u plus v times u plus v, okay? I'm going to use the area model, but you can also use the full method. So I have u plus v on one side of the area model, and I have u plus v on the other side of the area model. All right, u times u is u squared. U times v is uv. V times u is vu or uv, same thing. V times v is v squared, okay? So here, I have uv plus uv, so that's 2uv because I have two of those, okay? So the final answer would be u squared plus 2uv plus v squared. That's how I get this, u squared plus 2uv plus v squared. And that's how we get our identity. Once again, we'll use this quite a lot in the first two virtual learning assignments, okay? There are two more. Okay, here's the other one. So here, u minus v squared equals u squared minus 2uv plus v squared. Where did that come from? So here, once again, u minus v squared means u minus v times u minus v. You're multiplying u minus v by itself because it's squared. So I'm using the area model again. So u minus v is on one side of the area model. U minus v is on the other side of the area model. U times u is u squared. U times negative v is negative uv. U times negative v is negative uv. And then negative v times negative v is positive v squared. Negative times negative is a positive. Then we combine like terms. We have negative uv plus negative uv. Okay. So in this case, that's negative 2uv because you have two negative terms that you're combining. So you add them and keep the sign. So negative 2uv. The final answer would be u squared minus 2uv plus v squared. U squared minus 2uv plus v squared. So that's how we get this identity. Okay, once again, you will see this in the first virtual learning assignment. And the final identity, all right? So here we have u plus v times u minus v equals u squared minus v squared. So where did that come from? All right, in this case, we have u plus v on one side of the area model, u minus v on the other side of the area model. U times u is u squared, u times negative v is negative uv, v times u is vu or uv, v times negative v is negative v squared. All right, here when we combine like terms, these cancel because we have a positive uv and a negative uv. So these cancel to give us 0. So the only thing we have left is u squared minus v squared. So that's how we get this final identity, okay? Once again, make sure you understand these because you're expected to be able to do the virtual learning assignments.